CrNH3 6 3 plus. Here the chromium atom has an atomic number of 24. So when we write the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6, then 3d5, 4s1. This is the electronic configuration. We can write like this also: Ar 3d5, 4s1. This is d orbital is half filled, so it is more stable. This is ground state electronic configuration. In the excited state, chromium, find the oxidation number. So X plus 0 equal to charge is 3, so X equal to 3. So oxidation number is 3. So it is in plus 3 oxidation state. In plus 3 oxidation state, this it loses 3 electrons. So it is 3d 3 4s 0. This is in ground state, and in the excited state loses 3 electrons. It is 3d 3 4s 0. And so when we draw these orbitals, it is 3d3 4s 0. So 3 electrons are there, 3d3. And when this ligand approaches the metal atom, here the ligand is ammonia, and this ammonia is a strong field ligand. When we see in the spectrochemical series, this ammonia comes on the right side and it contains nitrogen also, so it is a strong field ligand. There is a trick to find out whether the ligand is strong field or weak field. If the nitrogen is present, it is strong field. So ammonia is a strong field ligand. But here this ammonia behaves as a weak field ligand. This is an exceptional case. Here it acts as a weak field ligand. So no pairing. So when the ligand approaches the metal atom, here the coordination number is 6. You see, NH3 coordination number is 6. So it needs 6 vacant orbitals. So we can take this P also. 4p 0, 4s 0. This is 3d 3. 3 electrons are present here, and now this ammonia, it needs 6 vacant orbitals. So these vacant orbitals, they hybridize and form new orbitals. So the hybridization is D2 sp3 hybridization, and the geometry is, shape is octahedral. Octahedral in shape. Now we can draw this orbital, hybridized orbital. So D2 sp3 hybridization takes place. This is D2 sp3 hybridized orbital. Hybridized orbital, and this is 3d 3. And when you see these electrons, there are 3 unpaired electrons, and because of these unpaired electrons, the complex is paramagnetic in nature. It is paramagnetic in nature, and we can find the magnetic moment. Mu is equal to root of n into n plus 2. Here n is 3, so 3 into 3 plus 2. The square root of 15. Square root of 15 is 3.87 Bohr magneton. So the complex CrNH3 6 3 plus is paramagnetic in nature. NiCN 4 times 2 minus. The metal atom nickel has an atomic number of 28. So the electronic configuration is Ar 3d8 4s2. So the outer electronic configuration for nickel is 3d 8 4s 2. Find the oxidation number for nickel. X plus for cyanide oxidation number is -1. So minus 1 into 4, that is equal to -2. So X equal to 4 minus 2, that is 2. So in nickel has +2 oxidation state. So reduce 2 electrons. It loses 2 electrons. Ni2 plus loses 2 electrons. So it is 3d8 4s 0. Ni is in ground state. This is in excited state. Draw the orbital diagram. So it is 3d8 4s 0. 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. And now when this nickel cyanide ligands, they approach the metal atom, it needs 4 empty orbitals. The cyanide ligand is a strong field ligand. Strong field ligand. And so if it is strong field, there is pairing. There is pairing. Pairing takes place. So now when the ligand approaches the metal atom, pairing takes place. So the cyanide Cn4, coordination number is 4. So it needs 4 vacant orbitals. We can take this 4p also. So because it needs 4 vacant orbitals, so hybridization takes place, dsp2 hybridization. These vacant orbitals are hybridized to 4 new orbitals. So dsp2 hybridization takes place, and the cyanide, they occupy the orbitals, and the hybridization, the geometry is square planar. Here n is equal to 0. Number of unpaired electrons 0. Therefore mu is also 0. Magnetic momentum mu is 0. Because n is equal to 0, the complex is diamagnetic in nature. Diamagnetic in nature. And so NiCN4 2 minus is diamagnetic, whereas CrNH3 6 times 3 plus is paramagnetic in nature. Here this complex is diamagnetic in nature.